Well, hi, and thanks for joining me here in my shop. Hey, I'm going to be doing something a little different here today. I'm going to be trying to use some test equipment I've really not done much with before, and all this is in anticipation of eventual realignment of this radio. Once I do a lot of component replacement in this area where the FM fading has been occurring, and perhaps even change the capacitors in the IF cans. I'm pretty sure the set will need realignment, and FM realignment is certainly a little bit more challenging than the AM alignment, well, a lot more challenging. But as it turns out, I have all the equipment necessary to do a proper job of it. But equipment I'm not so familiar with, so that's what I'm working on in this video. And I am going to try and not do the alignment, but actually operate the equipment connected to this radio and see what we get. So first of all, what am I using? Well, I'm going to be using this guy up here. Okay, so this is a RCA stereo FM signal simulator, in model WR52A. I had an easy time finding the manual for it on the internet. You know, that seems to get easier and easier all the time as more and more people are generous enough to post documents. It's surprising to me, but nevertheless I've gone through it, and this does have a sweep output, which is very important. A sweep output will cause the RF signal coming out of the generator to move back and forth. I believe in this case it actually is back and forth, like this. Not to be confused with the modulation of the FM signal, which also causes the frequency to move back and forth too. So, so I read up on this guy. I think I got him under control. He has two outputs. You can see a wire here and a wire here. This one, the RF output, is connected, hard for you to see, is connected via this clip lead to the antenna on here, on the radio. So it's just feeding a FM signal or 100 megahertz frequency. I can push that frequency up and down here a fair bit. This control here, and that way, if there happens to be a station right on 100 megacycles, I can move off and find an area where there won't be any interference. You know, I do have another FM source. It's right over here. It's this guy. But this guy has a fixed output at roughly 100 megahertz also, and you can't vary this externally. It doesn't give you that opportunity. And this guy has no sweep, and it will produce a stereo signal. It has a 19 kilocycle signal in it for producing the stereo signal that's required, or part of the stereo signal that's required for your receiver to receive stereo, but not nearly as flexible as this guy over here. So now the other output right here, it does a couple of things, but in this case we're going to use it to drive my oscilloscope. And my oscilloscope, by the way, is just located over here. There it is there. And I have a camera aimed at it so we can see it. Just flip to that camera. Now, I'll tell you just a little bit of background on this oscilloscope. I picked this up off of a neighbor's front lawn. About quite a while ago now, 5-10 years ago. I was just driving by, and there it was sitting there. Offered out to anybody who dared to stop and pick it up, and I'm the one who picked it up. And surprisingly enough, I brought it home. It works perfectly fine. Well, maybe not perfectly fine, but it works good enough to be used. It's a dual trace scope. I think on an earlier video I mentioned it might only go to 5 megahertz. It goes to 10 megahertz, assuming it's working well. And you know, 10 megahertz gets you up in the range of the IF signal for an FM radio, which is around 10.7. And it's a dual trace scope. It has two inputs here. So to use this, and one thing I didn't realize about it until last night when, hey, I managed to download the manual for this scope, and I was really so happy to learn it has a XY input. Now when you look at it, it just says Y1 and Y2 here, and you can see the two inputs. And that's all I've ever noticed on the scope was Y1 and Y2. I've never seen the letter X anywhere on here. I was suspicious there might have been an X terminal on the back of the scope, because I know some scopes have a Z terminal on the back. Z terminals on scopes control the brightness. But as I looked through the manual, I discovered that, in fact, when you set the time-based control to one extreme, where it's set now, it actually says XY. And what happens at that point is this Y2 remains a Y input, and Y1 becomes an X input. So this is really great. You know, most scopes internally force the beam across. They have internal circuitry, it forces the beam across. And the input signals only cause up and down motion. But to do what we want to do with this thing today, you need to be able to externally feed a signal which will push it across along with the up and down signal. And that's what's going on right now. You see this funny zero shape here. I think this could be called a Lissajous figure, I believe. This is coming from a combination of the sweep output of the signal generator we're looking at a moment ago, and the Y input, which is probably just a hum. Just lessen it down here. We can fool a bit with it. I can move it up and down. I can't move it left or right anymore. Oh wait, yes I can. What am I talking about? So let's put it in the middle here. The dirty control. Yeah, my scope needs maintenance, and now that I realize this is a pretty darn good scope, and I have the manual, I'm inclined to open it up and clean it up, and the like, and also verify the calibration of it, which I had never done. So this is kind of an uncalibrated scope. Okay, let's just give this thing a go. Now, what I have to do is turn on the radio. I've removed most of the test equipment from it. You still see the Y input to my scope connected. Where is it connected? It's connected basically on the audio output of the FM ratio detector, which is right down here. It's pretty much on this blue line I've marked in blue, which shows the output going to the amplifier of the receiver. So essentially, the scope, the Y part, the up and down part, is listening to what's coming out of the radio. The X part is being driven by this lead. So just checking now, quick check for safety, making sure I don't have anything connected where it shouldn't be. I'm going to remove this wire, it's not needed. This is just the ground wire coming out. It's just clipped to the negative of the filter capacitors. My other signal generator, this guy's not even switched on. He's not being used. So I'm not feeding a 10.7 or anything like that. I'm just going to feed in the signal from the signal generator, the signal simulator. Maybe I should use that word all the time. So, and it's on right now. It's operating. Okay, let's switch on the radio. It has speakers attached. There we go. Okay. I always switch it on with my light bulbs in, just to make doubly sure that some short circuit hasn't occurred, because a cat's been in here working on the radio and I didn't know it. I'll let it warm up now. I believe when it's in sweep mode, what you hear is a terrible whir sound. So I'm going to put this on just sort of an audio output. It's got 1,000 hertz signal going. See if I can make my camera a little more level here. You don't have to have your head cocked to one side. So we should hear 1,000 coming out of here. Hear it a bit. So I get it tuned in. Maybe I should leave this meter connected. This meter, when connected right, helps me know when I've got the radio tuned dead on. So let's do that. what I'll connect this meter to is the negative end of, I think, what's called the averaging capacitor in a ratio detector. .87. Okay, so I can raise the output of the signal. There we are. And now I can tune either the radio or tune the signal generator. I'm going to just tune the signal generator. It's actually a little bit easier. And I'm watching this meter. I'm listening to it also. Now on the scope, let me flip it over here so you can see what I'm doing. Okay, so I've taken it off the sweep setting. It's just on a regular time-based setting, so the scope is sweeping across on its own, and we're looking at the signal here. It's kind of funny to me. There we are. So that's a look at the. Let me change the pitch here. Oh, it's not what I thought it was. Okay, so I don't have a ground connection between the radio and all my equipment. And that's probably what we're seeing here is just a 60 cycle hum. So let me attach a ground here. Okay, I'm going to do it right from the capacitor negative point. The reason I can do this fairly fearlessly is the radio is being powered from an isolation transformer, so there isn't another power ground to the chassis or something like that that's going to cause some kind of ground loop or other excitement. But I think if I just put this on here, that should disappear. Let's see. Boom, disappeared. Okay, now you can see the real signal. Let's make it. Yes, my scope needs a little bit of DC bias adjustment. There it is. Okay, down, speed it up rather. Now, I'm sure if I change the frequency here, you'll see that change. Okay, so we're just listening to the radio with my scope. I guess that's one way to put it. So what I'm going to do next, I'm going to verify, because things are still warming up here, especially in the radio. Verify the tuning by looking at this meter and make sure it's maxed out. About 317 looks to be in the max area. Once again, if you look at the scope signal, it's like a nice balanced sine wave. That looks just excellent, in fact, to me. Fantastic. Interestingly enough, what you see on your screen once you watch this video is a very stable looking display, and when I look at it, actually on the display, it's quivering quite a bit. That's very interesting. It looks rock solid on the video. Very interesting. Something to do with frame rate and I don't know what. So you're actually getting a better look at it. Now, we'll go from this simple approach to trying to use the sweep of the radio. I'll put the signal generator onto sweep and you'll hear what it sounds like. Oh yeah, big funny hum. Nothing I can do to vary that. Oh, I'll take that away. I can change the strength of it. So let me slow down the sweep on the scope here. Let's see if I can make it a little more stable. I turn up the level here, I'm not exactly sure what I'm turning up. You can see lots of funny things happen. I'm going to assume you should keep it down around here, down like this. Can't even hear it now. Okay, now I'll set the scope to, it's amazing, I look on the computer screen, it just looks fantastic, but on the scope itself it's flashing along. Okay, I'll set this to the XY. Not much happening there. Turn up the sweep here. Oh, that's a sweep. Yuck. Not at all what I expected. Well, I'm on the learning curve. Now, somehow I was expecting a display that looked like that. I happen to have the manual here for both the scope and the signal generator. The signal generator manual shows some typical signals, what they should look like. So I'm going to take a moment and study that and see if I haven't done something quite wrong here. But this is why I'm doing this. So when the time comes when I have to do it for real, I have enough familiarity that I can recognize my mistakes and know when I've got things working properly. So let me just check out the manual here a little bit. Okay, well, it doesn't take me long to realize I haven't got all the equipment going here that I need. So you can see I've now got my regular signal generator switched on, and that's the actual IF frequency of this radio, 10.58. And I have to connect that in, according to the manual here, to connect loosely couple the cable from a generator, such as the RF generator, RCA, WR50A, well, I can use any RF generator, to the first IF of the receiver. Adjust the generator to produce a 10.7 megacycle marker. And they say marker, I think they just mean frequency. So so I've missed a whole piece of equipment here. Oh, that's great, I've got two signal generators. Okay, to the first IF. I believe I found that I could stick it on pin 6. Maybe it was pin 1. Pin 1 of the 12AT7, and pump the 10.7 IF frequency right in here, and it's going to pass through the IF. Okay, let me do that. Now, everything's pretty much set to go anyway, so I'm not at a complete loss. Now, one of the things I'm really bad at is properly terminating these connectors. I do have a whole bunch of proper terminators for this military. This is a military grade signal generator. It's designed actually around the Collins R398 radio, which I have. But of course, being a signal generator, it can be used for all kinds of general stuff. Put this on here. That's the ground connection. Better think a little harder before I do those kinds of things. And now we'll connect in. We'll connect in the out from the signal generator. Just drop the level way down here into pin 1. Just more light for a moment to make absolutely sure, not rely on my memory. I'll have a fire in a few minutes here. Right onto this pin here. Oh, okay, like that. Look at that. I touched it and it did that. I woke the whole radio up. Fading down again. give it a go. Soon I will be receiving a new set of capacitors. I'll be able to change all these ceramic capacitors in here. Many of you will be applauding while I do it. Let's turn down the volume a little bit. There we go. Now, okay. Must be some more instructions in that manual. I made the connection. It's not exactly 10.7. Connect the vertical input probe of the oscilloscope to point 1. Limiter grid circuit set H to line blah 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 blah. You should see that. Okay, so I got to find another place to connect the scope input here to point 1. And test point 1, I'm looking at a diagram here it's showing me test point 1 is simply a low impedance point into the last tube before the discriminator. Okay, low impedance point, last tube before the discriminator. The last tube in this radio is the 12AU6. Low impedance point would be, according to what I'm looking at, I think, oddly enough, potentially here to the top of a 220K resistor, and this is the AM audio output takeoff point here. So it just goes through that IF up into this IF, feeding the grid of the last tube. So I think maybe that's the point, or even below that resistor, 220 and 270K. 220, 270K, I think I know where those are. I think I know where those are. So I'll take this off here. Okay. 220 and 270. Jab it in there. I think it's right here. Oh, was it 270K? Confused myself already. 270K and 220. And that's I believe it's right here. Let's see what we're getting on the scope at this point. Okay. Let's see if I can expand this a little bit. To expand it this way, I have to adjust this control here. Really not looking at all like what I would expect. And I could adjust the RF output of this. Doesn't make any difference whatsoever. And what else can I adjust? I could change this setting, do anything. I didn't think it would. Okay, so I can tune. It's kind of a hum. It's just showing up in the radio here. Bother with that. I will tune the signal simulator output back and forth a little bit. And I think, you know what I need to do here? I need to set up. I need to set something a little different here on my video. So hold on, everybody. Hold on tight. I just there we go. Now we can see both things at once. And you wouldn't want to be looking at the scope when smoke and flames comes out of the radio. You wouldn't want to miss that excitement. This allows you to see the meter over here, which is at 0.6. You can't see the decimal point. It's at 0.6. Just a wee bit. Now, I think I got everything connected reasonably well. So I was going to tune the signal generator up here, signal simulator, just to keep them separate, the FM simulator. Watch that voltage, watch the screen. Yeah, absolutely no difference on the scope, so I think I have something not quite right. I'm trying to peek this back up. What happened? The radio has gone dead. What happened? Let me turn this up. Okay. I turned up the output of the simulator. Now even this thing can get up to 4 or 5 volts here. Not too happy. I don't think that's sufficient. Let's ram it up. I have the output full now on the signal simulator. Still not going up. Not a good sign. Something I've done is pulling down the signal. I can hear a hum with my ears that you probably can't hear. So that's it. That's the spot. Not too happy with that situation. It could be the radio is in non-operating condition. Seems to be going up and down a little bit. Because I don't have it tuned into a regular radio station, I just can't be sure what's going on with it. Funny, eh? Up and down. I'm watching this meter here. Okay, now another thing I can do is vary the IF signal. That's this one here, which I'm making impossible to see. It's at 10.5 because that appeared to be the proper IF frequency for this radio, just the way it exists. It's supposed to be 10.7. So I will tune that now around and we'll see what happens here. Here we go. Watching just about everything. Way up. Watching everything but my frequency counter. Coming close to 10.7 now. Oh, so close. And what was it? Was it 5.8? I think it was 10.58 was the spot that I thought was the existing IF frequency in the radio. Well, okay. There we are. There you have it. No doubt I haven't got something quite connected right. I'm trying to learn too many things at once. I'm trying to learn how to use the 2 pieces of equipment. Well, I know how to use a scope, so it's not that big a deal. But trying to learn how to use the FM signal simulator, trying to figure out how to set it up properly inside this arrangement, and trying to understand the detector, the ratio detector, and deal with lots of personal things going on outside my shop. Which, speaking of which, I'm out of time, so I think I got enough video here to post up, and I'll be back later tonight. I'll probably read these manuals over again. You know what I find is you got to read these things again and again and again. And in the interim, get a little experience, get your feet wet before you end up spotting exactly what it is you haven't done right and the like. But I know I'm pretty close here. And by all means, if you know what it is I'm not doing quite right, shoot me a comment, and I'll believe you maybe. And I'm sure we'll get this thing going right. And you know what? Maybe those parts are in my mailbox right now, for all I know. Okay, so thanks for watching, and we'll see you later.